Today in section 4.2 we're going to be talking about dividing polynomials, and before we do that I want to do a quick review of how we do long division with numbers. If you remember, and hopefully you remember, and hopefully you learned it this way, when you're dividing 3,352 divided by 9, we put the 3,352 inside of the little division symbol there, and then we put the 9 on the outside. And so then our question that we ask is, we look at this 9 and we say, how many times does 9 go into 3? And the answer is 0. 9 doesn't go into 3. So then we look at the 9 and we say, how many times does 9 go into 37? And 9 goes into 37 3 times. So we're going to put our 3 up here, and we're going to take 3 times 9, and we get 27. And so that 27 goes right here. And after we put that 27 under there, we want to subtract. So we're going to subtract 33 minus 27, and we get 6. After we get the 6, we bring down the next digit, which is a 5 in this case. So then we think, how many times does 9 go into 65? And that answer is 7 times. So then we take 7 times 9, and we get 63. And that 63 goes right here underneath the 65, and again, we subtract. And this time we get a 2. And then we bring down the next digit, and that happens to be a 2 in this case. And so then we take, we think to ourselves, how many times does 9 go into 22, and it goes in there twice. So we write down our 2, and we take 2 times 9, and we get 18. And that goes here, and we subtract, and we get 4. Now there's two ways to write that answer of a 4. We can write remainder 4, or we could write 4 over what we're dividing by, which is the 9, 4/9. So we get our answer there, and those are the two ways we can write it, and that's just a quick review of division with numbers. So we're going to do something very similar when we divide using polynomials. We're going to take this 6x squared minus 26x plus 12, and we're going to put it inside of the little division sign. Then the x minus 4 goes out here. So what we have to look at this time is not how many times x minus 4 goes into some particular part. What we do is we focus on the x and the 6x squared. And we think to ourselves, what do I have to multiply x by to get 6x squared? And the answer is you have to multiply x by 6x to get 6x squared. So we put the 6x up there, and then we take that 6x and we multiply it by x minus 4. And that's just distributing, and we get 6x squared minus 24x. And we're going to take that and put that underneath here. Now, instead of just subtracting, because what happens is a lot of times we lose track of subtracting when we have more than one term, we're going to draw the line and change both the signs. And we can see how subtracting x squared would be a negative there, and how subtracting a negative would make it a positive. So that's what we're going to do every time. We will draw the line and change the signs. Now notice what happens with this 6x squared. They will cancel. And that should happen every time, because that's how we got this number right here. So then we've got negative 26x and 24x, and that gives us negative 2x. And then we bring down the next term. So again, then we look at this x again, and we say, what do I have to multiply by x to get negative 2x? And the answer is negative 2. So we take the negative 2 and we multiply by x minus 4, and we get negative 2x plus 8. We put that in here, then we draw the line and change the signs. So notice again, the two x's are opposite signs. They will cancel out. 12 plus a negative 8 gives you 4. So again, you can write that in two ways. You can write it with a remainder 4, or you could write it as 4 over the value you're dividing by, which is x minus 4. So now our division algorithm, and here's what this says. If p of x and d of x are both polynomials, and d of x is not 0, then there exist unique polynomials q of x and r of x, where r of x is either 0 or of a degree less than the degree of d of x, such that this is true. P of x can be written as, or is equal to, d of x times q of x plus r of x. So here's what this is saying. P of x is simply your polynomial. D of x is your divisor. It's what you're dividing by. Q of x is your quotient. And then r of x is the remainder. And this is actually something you learned way back when you learned how to divide, is this is how you check an answer. You multiply your answer times what you divided by, and then you add the remainder. And that should equal what you started with. So this is really nothing new. It's just applied here to polynomials, and that can make it look a little bit confusing. We do want to remember that P of x is called the dividend. D of x is called the divisor. Q of x is called the quotient. And then we talked about this, R of x is the remainder. So those are the terms that go with each of those individual polynomials. Notice that in long division, we always use multiplication to make the first term of the divisor equal the dividend, equal the first term of the dividend, that should say the first term of the dividend, and then subtract this product from the dividend. So again, using this same process, we can divide 8 x to the 4th plus 6. Hang on, this is why I put this in here. We can divide 8x to the 4th, but notice there's no x cubed term. When there is a missing term, we have to put in what is called a filler term. So 0x cubed plus 6x squared minus 3x plus 1. So we put in that filler term to hold the place value of the x cubed. Then over here we still have 2x squared minus x plus 2. And we go through the same process. We look at this 2x squared. 2x squared times what will equal 8x to the 4th? And the answer is, well, 2 times 4 is 8, and x squared times x squared is x to the 4th, so it's going to be 4. Wow, I'm having trouble with my writing here. It's going to be 4x squared. So just like before, we're going to take 4x squared and multiply by 2x squared minus x plus 2. And we're going to put that in right here. So we're going to have 8x to the 4th minus 4x cubed plus 8x squared. Then remember, we draw the line and change all the signs. So again, these first terms cancel. We're going to have 4x cubed. We're going to have negative 2x squared. And we will bring down the negative 3x. So once again, we check out this term, 4x cubed. What do I multiply the 2x squared by to get 4x cubed? Well, 2 times 2 is 4, and x squared times x will be x cubed. So we will take the 2x and again multiply by our divisor. And that will go in right here. So we're going to have 4x cubed minus 2x squared plus 4x. Then we draw the line, change all the signs. So the first terms cancel, and notice actually in this case the second terms cancel as well. So what we have left now is negative 7x, and we bring down the 1. So again, we can ask ourselves, 2x squared times what equals negative 7x? And the answer is nothing. And here's why. Once this degree, x squared, is bigger than this degree, which is a 1, then we're done. And this is our remainder. So we would have remainder negative 7x plus 1. And so you do the process the same way until finally your remainder has a power, has a degree that is less than your divisor. A great shortcut for doing long division is what we call synthetic division. And in synthetic division, we only use the coefficients, or the numbers, of the dividend, and then we use the opposite of the number of the linear expression that we're dividing by. That is one limitation. You can only use it when you are dividing by a linear expression. So your divisor has to be simply x plus a number or x minus a number. So looking at this one, we've got 2x cubed minus 7x squared plus 5. So what we do is we write down the coefficients. 2, that's with the x cubed. A negative 7 goes with the x squared. Now notice again here, there's no x term. There's a 0x there. So we have to put in that filler term for the 0x, and then we have the 5. So we simply write our coefficients across a horizontal line there. Then we put this little box in the corner, and we look at this term, x minus 3. Since you have x minus 3, what goes in here is the opposite of what you see, and it's going to be a positive 3. So here's how synthetic division works once we have it set up. We draw a line down here. The first thing that always happens is that first term just comes straight down. We don't do anything to it. We just bring it down. Then we take this answer, the 2, and we multiply it by the thing in the box, which is 3. So 2 times 3 is 6, and that 6 goes here, underneath the negative 7. Then we add these two things together, negative 7 plus 6, and we get negative 1. Then we take that answer and multiply it by the 3, and negative 1 times 3 is negative 3, so that goes underneath the next digit, which is a 0. We add those two, and 0 and negative 3 gives you negative 3. And once again, you may be seeing a pattern. We're going to multiply by the 3 again. Negative 3 times 3 is negative 9, and that's going to go under the 5. And then we get our answer, our last number there is a negative 4 when we add those. So we've got these 4 numbers. What do they mean? Well, here's what they mean. It's still a polynomial. We know that answer is going to be a polynomial. But when we look at this term that we were dividing, we've got an x cubed there. Whatever that degree is, your answer will always be a degree that's 1 less. So your first term is 2x squared, and then you're going to have minus 1x minus 3, and then you're going to have a remainder of negative 4. So whatever this degree is here, being that it's a 3, this one will always be 1 less, and then the powers go down by 1. So you can see our answer there, and of course we do not have to write the 1 there, and we could write this last term as a fraction if we wanted to. So now the remainder theorem. Here's what the remainder theorem says. It says if a polynomial p of x is divided by a linear term, x minus c, then the remainder is the value of p of x. Again, we can use synthetic division here because we are dividing by a linear term. And let's look at an example of how this works. Use the remainder theorem to find p of negative 2. So here's what we do. We're dividing this thing right here. So we write down our coefficients. 3, 5, negative 4. Notice we're missing an x squared, so 0x squared, 7, and 3. Then in our box, in this case, we just use what we have there, negative 2. Because notice you've got x minus c and compared to p of c. So it is the opposite of what we would see in the linear term, but it's exactly what we see in the function here. So we go through this process again. We draw our line. The first term comes straight down. It's a 3. 3 times negative 2 is negative 6. We add these together and we get negative 1. Negative 1 times negative 2 is 2. We add those together and we get negative 2. Again, we're going to multiply each time by the thing in the little box. Negative 2 times negative 2 is 4. 0 plus 4 is 4. 4 times negative 2 is negative 8, which gives us negative 1. And negative 1 times negative 2 is 2, which gives us 5. Now the remainder theorem says that the remainder, which is this last term, should be equal to p of negative 2. So our answer is that p of negative 2 equals 5. Now we can check that relatively easily. If we look at 3 times negative 2 to the 5th power, I'm just taking that first term. Negative 2 to the 5th power is 2, 4, 8, 16, 32. Negative 32, that gives us negative 96. 5 times negative 2 to the 4th power. Well, negative 2 to the 4th is 16 times 5 is 80. Then we have a negative 4 times negative 2 cubed. Negative 2 cubed is negative 8 times 4 is a positive 32. Then 7 times negative 2 is negative 14. And then you have a 3. So grouping these two together, we have negative 110. Grouping these two together, we have 112. And then remember we had that plus 3 at the end, and if we add those up, we do get 5. So that's a way of checking that. But you don't have to do this part. This is just to show you, yeah, it is actually true that this 5 is our answer. Now the next theorem we talk about is what is called the factor theorem. And here's what the factor theorem says. C is a 0 of p if and only if x minus c is a factor of p of x. Well, think about what a 0 is. A 0 means that p of c equals 0. Using the remainder theorem and going to here, what that means is the remainder is 0. And if a remainder is 0, that means x minus c divides p of x evenly, which is what it means to be a factor. So using the definition of these things and also the remainder theorem, we find out that yes, p of c has to be a 0, or sorry, c is a 0 of p if and only if x minus c is a factor. Now let's get rid of some of that. So looking at this problem, example 5, we've got p of x equals x cubed minus 7x plus 6. Show that p of 1 equals 0. Well, that should be pretty easy. We put 1 in the little box. We write down a 1 for the x cubed, a 0 for the x squared, a negative 7 for x, and a 6 for the constant. Then we do our division. So 1 times 1 is 1. 1 times 1 is 1 again. And we get 0. So check. The first part is done. Then we use this fact to factor p of x. Well, what we've just shown then is that x minus 1 is a factor of p of x because this 1 divided in evenly. There was no remainder. Now what's this stuff that's left? The original degree was 3, so this degree has to be 1x squared, it goes down by 1, plus 1x minus 6. So it's asking us to factor this completely now. Well, this part's already done, x minus 1. But remember, we can factor this one, hopefully, using this method that we have learned before. We know that the signs are different. We know the bigger one is positive. So it's going to be a plus and a minus. And factors of 6 that add up to be 1, that's a positive 3 and a negative 2. So the complete factorization there, x minus 1 times x plus 3 times x minus 2. So for example 6, we're supposed to find a polynomial with a degree of 4 that has these 4 zeros. Well, if negative 3 is a 0, that means x plus 3 has to be a factor. If 0 is a 0, that means x minus 0 is a factor. If 1 is a 0, then x minus 1 is a factor. And if 5 is a 0, then x minus 5 is a factor. So really, notice we've got 4 terms. All we have to do is multiply these together, and we're going to get our polynomial with a degree of 4. So I'm going to rearrange this a little bit because x minus 0 is really just x. I'm going to put that out in the front and save that for later. But then when we multiply the rest of these, let's just do 2 at a time here. So x times x is x squared. X times negative 5 is negative 5x. X times negative 1 is negative 1x. And negative 1 times negative 5 is 5. So that gives us x times x plus 3 times x squared. We combine these to get negative 6x plus 5. Then we'll multiply these two. So x times x squared is x cubed. X times negative 6x is negative 6x squared. X times 5 is 5x. 3 times x squared is 3x squared. 3 times negative 6x is negative 18x. And 3 times 5 is 15. So notice that gives us x cubed minus 3x squared minus 13x plus 15. And then our last step is we just have to distribute the x. So our full polynomial will be p of x equals x to the fourth degree, minus 3x cubed, minus 13x squared, plus 15x. Assignment for section 4.2 is pages 331 and 332. You can see that there. You also have it on your assignment sheet that I handed out to you earlier in the year. You will have time to work on this in class tomorrow, and so you probably should get started on it and then ask questions tomorrow during class.